ये हो गया था कंप्लीट?
हाँ ये हो गया था।
सॉरी,
हाँ हो गया था मैम, ये हो गया।
सीवीडी।
यहाँ से बाकी था।
ओके, ठीक है, चलो, थैंक यू। वो 4 क्लासेस में लेती हूँ ना, तो पता नहीं कहाँ, मतलब आई यूज्ड टू फॉरगेट। वो फाइल होती तो हम लोग क्या लिख के रखते कि यही टॉपिक तक खत्म हुआ है। ठीक है, फाइन। सो जो आगे 3 टेक्निक देखी, दैट इज द बॉल मिलिंग, laser ablation and sputtering techniques. They come under the first approach, that is the top-down approach, right? So, as I told you, and as we have seen, the 3 techniques we'll be seeing for the top-down approach and 2 for the bottom-up approach. So, this thing, CVD, that is a chemical vapor deposition technique, it falls under the the bottom-up approach. Now, as compared to the top-down approach, in bottom-up approach, there is a chemical reaction between the target and the substrate, right? We have seen for the laser ablation and the sputtering that there is no chemical reaction between the target and the substrate. But यहाँ पे, in the bottom-up approach, the target and the substrate do react, and there is a formation of a new structure on the surface of the substrate. Right, these techniques are used for surface modification. So on the surface, there will be a reaction between the target atom and the substrate atom, and we will get some new structure. Right. So the chemical vapor deposition is a chemical process used to produce high purity, high performance solid materials. We can get high purity, high performance in the sense, in this method, it is possible to get the film of uniform thickness. Right? We can get the film of uniform thickness with the help of the CVD technique. Now, one thing we must have seen in the first 2 methods, that is a laser ablation and this one sputtering technique, that the substrate was not heated. The substrate was left as it is. Right? We just used to place the substrate in the assembly in the chamber, and then after the target atom was melted, evaporated, and then it was allowed to fall on the substrate. यहाँ पे what we are going to do is the substrate will also be processed. The substrate will also be heated, right? So we will heat the substrate and we will evaporate the target. The target will be in the vapor form and the substrate will be heated in the case of the CVD technique, right? Before proceeding, let me give you one example. This technique is widely used in the semiconductor industry, right? For you can say that for modifying the surface of the semiconductor. Say I'm having a pure semiconductor, and I want to fabricate a P type of semiconductor, right? Surface के ऊपर मुझे P type semiconductor की property चाहिए, right? So what I will do is I will take a pure silicon. Your pure silicon will be your substrate. Okay. P type banana hai, matlab I have to add the pentavalent impurity, say phosphorus, right? So phosphorus will be my target. I'll be taking the phosphorus atoms as a target and a wafer of silicon or wafer of germanium as a substrate. Fine. Then after what I will do, we will be heating the substrate. Now pure semiconductor is an insulator. When I heat the semiconductor, when the pure semiconductor is heated, there will be the breaking up of the bonds of the pure semiconductor. Silicon या germanium जो भी है उसका bond break होगा, and then the charge carriers will be released from the lattice site and it show you the conducting property. Fine. So similarly, when I hit the substrate, the bonds are broken and all the electrons will move from the lattice site and a vacancy will be created in the substrate, in the pure silicon wafer, right? Now at the same time, what will be done? The phosphorus, जिसकी मुझे जो impurity मुझे add करनी है, right? The phosphorus will be heated with the help of some RF circuit and inductors, and it will be evaporated, and the evaporated form of the phosphorus will be allowed to flow towards the substrate. There is a provision in the CVD technique that you can control the flow of the phosphorus, right? So by controlling the flow of the phosphorus, by controlling the flow of the target atom, we can even control the thickness of the film. Okay, ज़्यादा thick material चाहिए तो flow rate बढ़ा दो आप. Fine. So what happens? Your impurity, your phosphorus atom will move towards the substrate. Now substrate को हमने heat किया है. So vacancies are created on the substrate, right? So the phosphorus atom approaching the substrate, he will see the vacant side, and the phosphorus atom will move inside the vacant side, and then it will form a bond with the silicon atoms, right? On the surface. Fine. So जहां जहां भी vacancy होगी, there the phosphorus in that lattice side, the phosphorus atom will sit there, and then after it will form the bond. Okay. So during this process, phosphorus is moving towards the silicon. Yeah, target is moving towards the substrate. There is a chemical reaction. So because of the chemical reaction, some of the there are chances of the toxic gases being released. So that has to be taken out from the chamber, right? So on the surface, we'll be having some new structure, क्योंकि वो आपका structure जो है वो distort हो जाएगा. Phosphorus आप उसके अंदर add कर रहे हो इसीलिए. Fine. So we'll be getting some new property, new structure on the surface, right? So this is how the CVD works. ये just मैंने आपको example दिया for fabrication of the FAT, FET, field effect transistors and MOSFETs, gates, right? This kind of technique is used in semiconductor industry. CVD is used. Fine. So, what is CVD process? The CVD is the formation of a non-volatile solid film on a substrate by the reaction of the vapor phase chemical that contain the required constituents. In short, मतलब typical chemistry वाली definition है. What you can say is the reaction of the target with the substrate, right? Yeah, you can say that the formation of a film on a substrate due to the reaction of the target with the substrate is known as the CVD process, is known as the chemical vapor deposition technique. Right? Now, a very small video of what this CVD technique is. थोड़ा टाइम लगेगा, मुझे लगता है नेट स्लो है. So we need to wait. ओके, सो यहाँ पे ये जो है ऊपर, दैट इज योर सबस्ट्रेट. ओके, जो ग्लास मतलब वाटर कलर का कुछ दिख रहा है, सी ग्रीन, एंड दिस इज योर टारगेट. So target is releasing bluish color atom, and you can see when target atom reacts with the substrate, the color changes, right? So there is a chemical reaction between the target and the substrate. So there are different types of CVD process. APCVD, atmospheric pressure CVD, metal organic CVD, plasma ion CVD, etc., etc. Just for your information. So what are the advantages? As I told you, we can control the flow of the target. We get the uniform thickness. We can even control the thickness of the film, right? Even we can control the temperature. So by controlling the temperature, we can control the crystal structure also. Disadvantages: there is a chemical reaction between the target and the substrate. So there are chances of the toxic gases being removed during the chemical reaction and costly, right? Because CVD may be before doing the deposition, you need to create a vacuum. So for creating the vacuum, again, you require the pumps, and these pumps are very costly, right? So this is the machine layout of a CVD machine. If you can see, ये part जो है, this part, it consists of the vacuum units. Okay, for creating the vacuum in this assembly, ये पूरी chamber है जहाँ पे आपको vacuum create करना होता है. So you will be having 3 pumps, 3 gauges. Gauges are used for measuring the vacuum, and pumps are used for creating the vacuum. Now inside the chamber, ये T जैसा जो है, that is a substrate holder. Yellow color wala, right? And it will be having the heating element from where you can heat the substrate. उसके ऊपर हमने substrate रखा है, right? Brown color का जो है वो. So this T is an heating substrate element with heater, and on that we have kept a substrate. Now, if you can see the gas one is the target, right? We will allow the gas, we will evaporate, we will heat the target, convert it into the vapor form, and that vapor will be allowed to flow towards the substrate for the film deposition. Fine. So ये figure कई टेक्स्ट बुक्स में है. Okay, simple ये दो plates है, electrodes है, and then the substrate will be there and the target will be there, but इसमें से आपको कुछ पता नहीं चलेगा. क्या हुआ? Right, these are the 3 important CVDs which are widely used in nanotechnology: APCVD, plasma enhanced CVD, and low pressure CVD. I just wanted to show you one video applications, different applications of CVD technique, right? So this is a substrate, okay? And we want to modify the surface of the substrate. So we will take the target, and the target will be evaporated, and the evaporated target atom will be allowed to flow towards the substrate, right? So when your evaporated target move towards the substrate, there will be a chemical reaction between the target and the substrate, and because of the chemical reaction, you can see the surface modification, say, right? Surface ही modify होगा, जो bottom का part है substrate का, that will not be modified, right? That will not be changed. So few of the advantages of CVD: we get the uniform thickness, flexibility, control the thickness, control the temperature, control the flow rate of the target atom, etc., etc. And the major disadvantages is the toxic gases that are involved during the fabrication, right? Particularly, when semiconductors are fabricated, the lots of toxic gases are. Suppose मुझे ये arsenic use करके semiconductor बनाना है, right? So when there is a chemical reaction between arsenic and silicon, at that time there are chances कि arsenic जो है वो chamber में से बाहर निकल जाए, right? So fabrication of semiconductor releases the gases which are hazardous. So is it okay? Is it fine? Theory है, सिर्फ story
Yes,
जैसा
sir.
ही है, right? So let us go to the next part. Can you tell me what is gel? What do you understand by gel? What is a gel?
It's a kind of mixture of liquid and solid.
Semi-solid kind of thing, right? A sticky substance, semi-solid, sticky substance, we tell it as a gel, right? So in the Sol gel method, we are going to make a gel, or a gel is prepared, gel is made by using the metal salt and water. Okay, so ये सब, instead of that, I am directly going to the figure. Now, if you see the figure, you just need to explain the figure in this technique. Okay, और कुछ नहीं करना है. So I'll be starting with this thing, metal oxide, metal alkoxide. Just wait. Right, so we'll be starting with this point, metal alkoxide solution. Now, what is this? Say for example, I have bulk material named A and B. Okay, मेरे पास दो bulk material है, A और B, right? Just give me 1 minute. Okay, fine. So sorry. Uh, we need to discuss for the syllabus. That's why your syllabus for the sessional examination will be the laser, fiber optics with sensors, quantum mechanics, मतलब तीनों जो derivation हमने लिए वो particle in a box Schrodinger's equation, and then the fabrication techniques, पांच fabrication techniques, properties, applications, along with the quantum dot and quantum well, right? So this will be your syllabus for your sessional examination. You will get a mail from the course coordinator soon. Okay, fine. So अभी पूछना नहीं, LMS पे रख देंगे syllabus. So fine. In the soul gel, मैं audible हूँ?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Response नहीं मिला इसलिए. So in the soul gel, let me say that I am having two chemicals named A and B. समझ लो आयरन है एक और एक कॉपर है. ओके, सो आयरन और कॉपर का मिक्सचर जो कंपोजिट मुझे बनता है उसका मुझे नैनो मतलब वो नैनो पाउडर मुझे बनाना है, राइट? सो व्हाट आई विल डू, आई विल टेक अ नाइट्राइट ऑफ ए नाइट्राइट एंड बी नाइट्राइट मतलब फेरिक नाइट्राइट एंड द कॉपर नाइट्राइट, राइट? एंड आई विल प्रिपेयर the separate solution of A and B. A nitrate और मतलब फेरिक नाइट्राइट और कॉपर नाइट्राइट का मैं सेपरेट सॉल्यूशन बनाऊंगी. ओके, कुछ वन नॉर्मालिटी जितना रखते हैं 10 ml में या 15 ml में जितने में बनाना है. सो आई हैव टू सेपरेट सॉल्यूशंस. यहाँ पे ये स्पेरिकल जो ब्लू कलर का बॉल है ना, in that case I will be having two separate solutions. Then after what I will do, I will take a magnetic stirrer. यहाँ पे you have a magnetic stirrer. Okay, along with the heating, magnetic stirrer with heater. So what I will do, I will set the temperature to 80 to 90 degrees centigrade. Okay, magnetic stirrer का temperature में 80 to 90 degrees centigrade रखूंगी. And then after I will take a base solution. Base solution मतलब iron का कुछ मुझे composite बनाना है. तो iron nitride, ferric nitride will be my base solution. So first I will take the ferric nitride. Okay. And then after slowly ferric nitride का solution 80 से 90 तक पहुंचे. Okay, when I reach the temperature of 80 to 90, then after slowly I will be adding the copper nitrate मतलब B solution to A. Ferric nitride के अंदर slowly I will be adding, ये वीडियो क्यों ऑन हो गया? Okay, I will be adding the copper nitrate drop wise में add कर. ओके, और हीटिंग चालू होगा, मिक्सिंग भी चालू होगा. मैग्नेटिक स्टरर कंटिन्यूअसली वो फैन जैसा घूमता रहता है, मैग्नेट होगा बीकर के अंदर, वो मिक्सिंग करता रहेगा, राइट? सो कंटिन्यूअसली 80 to 90 डिग्री तक आई विल बी मिक्सिंग this solution of A and B, and I will get a homogeneous solution almost after 2 hours. Okay, so then after 2 hours the gelling process starts. Slowly वो water का जो temperature है, solvent होगा आपका पानी, right? So water का temperature जो है अंदर का वो 80 degree से 90 से 100 तक पहुंच जाएगा, right? When you continuously heat it for 2 hours, so there will be the evaporation of the water, right? Deionized water या distilled water आपको लेना है. So when there is the evaporation of the water, the gelling process starts, right? After some times you will get a wet gel. So we are following this path. Okay, you took a solution, you are heating it at 80 to 90 degrees centigrade. So there will be the gelling process, right? And after some time, I will get a wet gel, right? Now, once I got the wet gel, there are two different paths. Okay, when I get the wet gel, say for example, यहाँ भी आप 80-90 डिग्री सेंटीग्रेड तक ही हीट करोगे. यहाँ पे though you got the wet gel, continue heating at the same temperature. वही temperature पे heating और mixing चालू रखो. तो ये जेल की वजह से आपका जो मैग्नेटिक स्टरर है ना वो चिपक जाता है, वो अभी मिक्सिंग नहीं करेगा. बट स्लोली इसमें से जो भी वाटर प्रेजेंट था ना वो धीरे धीरे इवोपरेट होगा. Okay, when you still heat at 80-90 degrees centigrade, that process we tell as an evaporation process, right? After some times, when most of the water is evaporated, sometimes you may even get a flume. Okay, वो धीरे धीरे जलेगा उसके अंदर यहाँ पे. Okay, and you can literally see the fume coming out from this vertical, right? So slowly after some time, because of the evaporation of the water, you will get a moisture powder. थोड़ा sticky moisture वाला powder मिलेगा, and that we tell as a xerosol. Okay, once you got the xerosol, remove the powder and heat it at a high temperature. Furnace आता है muffle furnace, 1000 degree, 500 degree Celsius तक उसको heat करो, you will get a dense ceramic. So ये एक बात हुआ. You prepared a solution, homogeneous solution, gelling किया, you got a wet gel. Wet gel is again heated at the same temperature. You got a xerosol, and xerosol को निकाल के high temperature पे mix करके you get the nanoparticles. Second path is gelling kiya, same. Okay, gelling kiya, you got a wet gel. Now, once you got a wet gel at 80-90 degrees centigrade, what you do? Remove the wet gel. Magnetic stirrer में से wet gel ले लो, and then heat it at a higher temperature. 80-90 से सीधा आप से 100-900 degrees, sorry, 200-300 या more than 100 degree centigrade पर ये wet gel को muffle furnace में heat करो. So the particle you get is known as an aerosol. Okay, that is known as an extraction of the solvent. Wet gel मिलने के बाद remove it from the stirrer and do the calcination. उसको calcination बोलते हैं. Heat it या calcine it, do the calcination at a higher temperature to get the aerosol. So ये एक path आपका complete हुआ gelling वाला. Right? Gelling दो part में करते हैं, दो steps, मतलब two different ways method can be employed. एक तो evaporation करके dense ceramic मिलेगा या xerosol मिलेगा, and extraction करके you will be getting the aerosol. Right? Now, is the first path clear? Gelling वाला, any questions? यहाँ पे you will be getting powder only, right? You are not going to get any device या film आपको नहीं मिलेगा, right? You will be getting the powder only. So is it clear? Any questions for the first part?
No, ma'am.
Okay. Now the second part, that is a precipitating. So what you will do? We got a gel, solution मिला हमें, right? Now in this solution, you add some precipitating agent. Precipitating agent मतलब you add NaOH या NH4OH to get the precipitates. I think आपको पता होगा what is precipitate, right? Milk है, milk के अंदर lemon add करो तो you will get the precipitate of milk in the form of paneer, fine? So similarly, you have a solution, you are adding some precipitating agent, right? Like NH4OH and NaOH, so you get the precipitates. So what you will do with that precipitate? Filter कर लो. Filter करने के बाद you heat it at a higher temperature. So in that case, you will be getting an uniform particles. लिखा इतना easy है, right? But if any layman work on this, na, you are not going to get the nanoparticles in that manner. Okay, it is a 2 days long process for getting the nanomaterials by co-precipitating. इसको बोलते हैं co-precipitation method या co-precipitation technique, right? So actual में क्या होता है? Sol मिला, sol मिलने के बाद, मतलब solution मिलने के बाद, you are adding the precipitating agent, right? In such a way that you get a pH of 7. जब तक 7 pH ना आए तब तक इसके अंदर precipitating agent आपको ऐड करना है. जैसे ही 7 pH आए, you mix it for 2 hours. 7 pH आने के बाद 2 घंटे तक उसको stirring करना है, mixing करना है. Okay? After 2 hours, the solution is left for aging. Aging मतलब क्या? कि उसको एक कोने में डिस्टर्ब ना हो वैसे रख दो, हिलाना नहीं है 24 आवर्स तक. ओके, फिर दूसरे दिन एजिंग हो गया होगा तो क्या होगा? प्रेसिपिटेट सब नीचे सेटल हो गए होंगे और ऊपर आपको ट्रांसपेरेंट क्रिस्टल क्लियर वाटर मिलेगा. सो स्लोली वो क्रिस्टल क्लियर वाटर जो है वो निकाल देगा. उसके बाद वो प्रेसिपिटेट का वॉशिंग करना है, मतलब डिस्टिल वाटर डालो, स्टरिंग करो, सेटल होने दो, ऊपर का पानी निकाल दो, अगेन डिस्टिल वाटर डालो, 3-4 बार उसका वॉशिंग करके उसका इथेनॉल से वॉशिंग करना है. ओके, एंड देन यू विल फिल्टर द प्रेसिपिटेट and then after you will be heating it at a higher temperature, right? So it is a 2 or 3 days long process to get the nanomaterials by co-precipitation technique. So this is the second part. Third part is spinning. So spinning is very easy. Once you get a solve, 2 घंटे तक 80-90 डिग्री सेंटीग्रेड पे उसको मिक्सिंग करना है. फिर what you will do, you will be taking the centrifugal machine, right? Centrifugal machine आपको लेना है. Centrifugal machine you must have seen in laboratories for testing. Blood test वगैरह के लिए जाते हो ना, वहाँ पे centrifugal machine होता है, right? Typical type की उसकी test tube होती है. ऐसे ऊपर वाला जो part है, it will be having the diameter, and then at the bottom it will be having a sharp edge, right? So you fill this solution in this test tube and centrifuge it. उसको centrifugal करना है, right? After doing the centrifugal fusion, what you will see in the test tube, ऊपर पानी होगा और नीचे सब प्रेसिपिटेट या जो मेटल सॉल्ट्स है ना, वो सेटल हो गए होंगे. सो ऊपर से पानी निकाल देना है और मेटल सॉल्ट को फिल्टर करना है. ओके, एंड देन आफ्टर उसको हायर टेम्परेचर पे हीट करना है. सो यू विल बी गेटिंग दी सिरामिक फाइबर. मतलब कि आपका जो नैनो पार्टिकल है ना, उसका शेप ऐसे फाइबर के फॉर्म में होगा ऐसा. I'll show you the photograph. I have one nanofiber SEM है मेरे पास. So when we go to the scanning electron microscope, no, I will show you कि ये nanofiber कैसे दिखते हैं under the microscope. Fine. So ये हुआ आपका third technique, gelling, precipitation, spinning. Now the last technique is coating. ये नहीं है, ये गलत है. कोटिंग के लिए व्हाट यू विल डू इज, सॉल्ट मिला आपको, ओके, 2 घंटे तक उसको मिक्स किया. समझ लो कि मुझे आई हैव अ ग्लास स्लाइड या कवर स्लिप. ओके, सो ग्लास स्लाइड के ऊपर AB से मुझे जो कंपोजिट मिला ना, उसका कोटिंग करना है, राइट? सो व्हाट आई विल डू, आई विल टेक अ ग्लास स्लाइड एंड डिप द ग्लास स्लाइड इन दिस सॉल्यूशन. सॉल्यूशन के अंदर मैं डिप करूँ. Okay, after dipping the glass slide in the solution, I will heat it in the furnace. Furnace के अंदर मैं उसको heat करूंगी. So I will get a dense film. Glass के ऊपर मुझे जो भी ये component लिया, AB का जो composite मिला, AB, okay, या ferric nitrate और copper nitrate से मुझे कुछ FeCu मिला, समझ लो. Okay, so FeCO की मुझे film मिलेगी इसके ऊपर. Okay, so this is all. ये सब there are different parts by which, different methods by which you can prepare the nanomaterials by sol gel by sol gel technique. यहाँ सब आपको पाउडर मिलेगा और सिर्फ यही कोटिंग की टेक्निक से ही you are going to get the dense film. फिल्म आपको एक ही पाथ में मिलेगी, बाकी हर जगह you are going to get the powder, right? So you have seen in this technique, we don't require any hi-fi instrument. Vacuum नहीं चाहिए, right? So vacuum create नहीं करना है तो vacuum pump भी required नहीं. Vacuum pump नहीं है तो measurement की, vacuum के measurement की भी जरूरत नहीं. That means you don't require the gauges. Okay, just you require the simple chemicals and glasswares, right? So this technique is very cheap, easy to fabricate. Even at a lower temperature, you can make the you can prepare, you can synthesize the nanomaterials, right? So the nanomaterials can be synthesized at a low temperature also using this method, right? So economically it is very cheap, easy to make. लैब में, कोई भी लैब में, केमिस्ट्री लैब में also you can go for you can prepare the nanomaterials, right? So this method, there is a chemical reaction, you must have seen, right? There is a chemical reaction. So this method can be used for producing the film. With this method you can get the particles of the same, all the particles with the same shape, same size, high purity. At a low temperature also you can prepare the nanomaterials, fine. So economically it is very cheap. So this was the last technique. That's all for the synthesis technique, right? So synthesis part हमने खत्म किया. Now the third will be the characterization part. So any question?
No.
Fine. So see, in the third part, we are going to see the instrumentation of three different machines, right? That is a scanning electron microscope, transmission electron microscope, and the XRD machine. See, we have fabricated a nano device. Okay, the nano device has been fabricated. Now, how you can confirm that the device fabricated by you is nanometer? ओके, जो भी डिवाइस आपने फैब्रिकेट किया है, एनी वन डायमेंशन हैज टू बी इन द नैनोमीटर रेंज. Okay, so we need to check the dimension of the device, the dimension of the particles that has been fabricated by us, and that can be done with the help of the microscope. We cannot see with our eyes, right? So we need to see the devices, the particles fabricated by us with the help of the microscope. Here the optical microscope will not do. We have to use the electron microscope. Fine. So here we are going to see two different types of microscopes, that is a scanning electron microscope and the transmission electron microscope. So before I want to show you a video, but before going to the video, let us see the instrumental part, right? If you see here, sorry, यहाँ पे ये जो है, ये टावर, ये वाला, that is the main part. This is the first part of the scanning electron microscope, second part and third part. ये टावर जो है उसमें सब कंपोनेंट्स है, फिलामेंट, लेंस, एक्सेट्रा एक्सेट्रा. दिस इज द चेम्बर, द स्पेसिमेन चेम्बर, जिसका भी सपोज आपके बाल मतलब हेयर का आपको डायमीटर फाइंड करना है, सो यू नीड टू कीप योर सैंपल इन दिस हेयर. ओके, ग्लास स्लाइड आती है, ग्लास स्लाइड के ऊपर रखना है आपके बाल को, एंड देन यू कैन वॉश. और ये जो थर्ड पार्ट है नीचे वाला टेबल जैसा, it consists of the vacuum units, because here also you require to create a vacuum in the range of 10 to the power minus 6 torr. Okay, आपको 10 to the power minus 6 torr में vacuum create करना है. Fine. So ये जो सब है ना, ये पूरा पार्ट वो टावर में, ओके, जो first part hai wo. So what it consists of? Electron gun. Now this electron gun is nothing but it is a filament which is made up of platinum, okay, which can bear high temperature. So सबसे पहले जो आपका टावर है ना असेंबली, उसमें आपको वैक्यूम क्रिएट करना पड़ेगा. वैक्यूम क्रिएट करने के बाद ही इलेक्ट्रॉन वगैरह जो भी आपको ऑपरेट करना है वो ऑपरेट करेंगे, राइट? सो यहाँ पे आपका स्पेसिमेन है जिसकी डायमेंशन आपको, ये पाउडर है तो पाउडर के जिसे बोल रहे थे ना कि भाई नैनो पार्टिकल अगर है तो वो क्यों हम देख सकते हैं, राइट? बिकॉज यू हैव अ क्लस्टर. अब ये क्लस्टर में से कोई एक सिंगल पार्टिकल की साइज मुझे मेजर करनी है, सो दैट वी विल बी डूइंग विद द scanning electron microscope. So the first part is an electron gun, which is nothing but a filament. The main function of the filament is emission of electron, right? We need to apply a high voltage to the between anode and cathode, right? So due to which the energetic electrons will be released from the filament. Then after you have an anode. Anode is used for collecting the electrons, right? You have an anode which is used for collecting the electrons. After anode, there is a magnetic lens. Now, the role of magnetic lens is important, right? The main function of the magnetic lens is to converge the beam of electron. यहाँ तक आप देखो जो इलेक्ट्रॉन बीम है वो स्प्रेड होता था, right? So with the help of the magnetic lens, we can compress the beam of electron and convert it into a very sharp beam. Okay, electron beam को sharp करने के लिए we are making use of the magnetic lens. Okay, so first part, this is the second part, the third part is the magnetic lens, fourth part is the scanning coil. Scanning coils are used for tilting the beam of electron. समझ लो आपका स्पेसिमेन कुछ ऐसा है, कोटिंग किया है मैंने इसके ऊपर, राइट? सो आई वांट द थिकनेस या इसके ऊपर जो भी मटेरियल कोट किया है उसका पार्टिकल साइज मुझे मेजर करना है, राइट। सो ये पूरा मुझे स्कैन करना पड़ेगा, राइट। सो इलेक्ट्रॉन बीम फर्स्ट विल फॉल हियर, देन आई विल स्कैन इट सेकेंड थर्ड, ऐसे टिल्टिंग करने के लिए बीम को, राइट। ये जो बीम है इसको ऐसे मूव करने के लिए वी आर मेकिंग यूज ऑफ द स्कैनिंग, right? Scanning coils are used for tilting the beam of electrons. Then after, ये जो है, let me number it, fifth part. It is a backscattered detector, right? And I will explain this part. And another thing you have is a secondary electron detector. So this is important. The secondary electron detector is important. Now see what happens. The beam of electron is falling on this, on the specimen. It is falling on the powder. Now when this electron falls on the powder, what happens? The same electron falling on the specimen will be reflected. The electrons that are falling on the specimen will be reflected. That we are telling as a backscattered electron. जो इलेक्ट्रॉन इम्पार्ट हो रहे हैं वही इलेक्ट्रॉन इंसिडेंट हो रहे हैं, वही इलेक्ट्रॉन वापस रिफ्लेक्ट हो रहे हैं, right? So they are known as a backscattered electron. And then after, when this electron fall on it, radiation means interaction of radiation with matter, right? उसी तरह electron are colliding with the specimen. So when the electron collide with the specimen, collide with the sample, the electrons will be released from the surface of the sample. पाउडर के इलेक्ट्रॉन जो जो भी मेजरमेंट के लिए आपने रखा है उसी में से इलेक्ट्रॉन निकलेंगे. दैट इलेक्ट्रॉन्स आर नोन एज अ सेकेंडरी इलेक्ट्रॉन एंड दे आर आल्सो नोन एज द कैरेक्टरिस्टिक्स इलेक्ट्रॉन, राइट. दिस इलेक्ट्रॉन gives the characteristics of the specimen which is used, which you have kept here for the measurement, उसका particle size. Okay, so backscatter electrons are a kind of noise. ओके सबसे पहले बहुत सारे बैक स्कैटर्ड इलेक्ट्रॉन मिलेंगे. सो देयर आर अरेंजमेंट इन द इंस्ट्रूमेंट्स विथ व्हिच यू कैन स्कैन द बैक स्कैटर्ड इलेक्ट्रॉन. ओके धीरे धीरे उसको स्कैन करके रिमूव करना होता है, राइट. सो दे आर यूजलेस, दे कैन बी रिमूव. Secondary electron will be collected by the secondary detector. Okay, and then they will be sent to the TV scanner को व्यू करने के लिए. ओके जो भी प्रॉपर्टी आप पार्टिकल साइज देख रहे हो तो व्हाट इज द पार्टिकल साइज फोटोग्राफ के फॉर्म में आपको मिलेगा, राइट. सो द सेकेंडरी इलेक्ट्रॉन गिव्स यू द कैरेक्टरिस्टिक्स. फोटोग्राफ है ना कुछ ऐसा आता है, देखो ये सेम का फोटोग्राफ है, तो पार्टिकल्स है. ओके वो ये फाइबर के फॉर्म में है, फाइबर है, राइट. सो आपके पार्टिकल ऐसे कुछ होंगे, एग्लोमरेटेड है, नजदीक है, राइट. पाउडर के फॉर्म में यू विल बी गेटिंग, फाइन. एक और कैरेक्टरिस्टिक्स है ये इंस्ट्रूमेंट की कि जो भी मटेरियल आपने लिया है ना उसके अंदर जो एलिमेंट प्रेजेंट है ना उसका परसेंटेज भी फाइंड कर सकते हो. यू कैन फाइंड द परसेंटेज ऑफ द एलिमेंट प्रेजेंट. सपोज पीएन जंक्शन डायोड या सेमीकंडक्टर, पी टाइप सेमीकंडक्टर हमने फैब्रिकेट किया है, राइट. सो इसके अंदर इफ आई वॉच ना तो व्हाट इज द परसेंटेज ऑफ सिलिकॉन, व्हाट इज द परसेंटेज ऑफ फॉस्फरस, पी टाइप इम्प्योरिटी जो हमने ऐड की वो, दैट कैन बी मेजर्ड विद द हेल्प ऑफ द स्कैनिंग इलेक्ट्रॉन माइक्रोस्कोप. बस उसके लिए एक एक्स्ट्रा सॉफ्टवेयर इसके अंदर ऐड करना होता है. सेकेंडरी इलेक्ट्रॉन ही आपको डिटेक्ट करना होता है. उसको वो टेक्निक को बोलते हैं इडेक्स, एनर्जी डिस्पर्सिव एनालिसिस ऑफ एक्स-रेज. व्हाट आर दिस रेडिएशंस कमिंग आउट? They are nothing but they are the X-rays, right? So that X-rays will be detected. That X-rays will be detected and they will be left. They will be given for the measurement, right? Just wait 1 minute. Right? So this energy dispersive analysis will give you the percentage of the elements that is present with the help of the scanning electron microscope. Right? So वीडियो का टाइम तो नहीं रहेगा. Next time I will show you in the next class. Right? So instrumentation means again once a second time I will explain you with the help of the figure, right?